Okay, so here we have question 1. Find all these limits based on this graph. This one says the limit as x approaches -2 from the left of f of x. Okay, and this is the graph of f of x. Here's -2. As we get close to -2 on the left, the y value is getting close to -1. So this is -1. The limit of f of x as x approaches -2 from the right. That little plus means from the right. So here's -2 again, and getting close to -2 on the right, the value is -1. These two are the same, so the general limit of f of x as x approaches -2 should be the same. So these three are -1. The limit as x approaches -5 of f of x. So if we approach it from the left, that's -1. From the right, it's 0. So in general, it doesn't exist. And at 5, as we approach -5 from the left, getting close to 1. As we approach 5 from the right, it's getting close to 1. At 5, it's 0, but that's not what we want in the limit, just as you get close to 5. So the answer is 1. Okay, number 2, taking this graph, what is the limit of f of x as x approaches -2 on the left? That's 3. On the right, that's 3. In general, at -2, that's 3, the limit. As x approaches -3, again, it's undefined because it approaches a different value from the left and from the right. And at +3, it's -3. Okay. Evaluate this limit. The limit as x approaches 4 of x squared plus 7x minus 44. Okay. So I'll do that one over here. 3, the limit as x approaches 4 of x squared. I forget. Plus 7x minus 44 plus 7x minus 44 over x squared minus 16. And the thing is, I tried to substitute, but when I substitute 4 for x, this would be 4 squared is 16, 7 times 4 is 28, 16 plus 28 is 44, minus 44, we get 0. And 4 squared is 16 minus 16 is 0 over 0. So we need to work it in this case by factoring. This is the limit as x approaches 4 of x. Two numbers whose product is -44 and sum is 7. That would be plus 11 times x minus 4 divided by, this is a difference of squares. So that's x plus 4 times x minus 4. The x minus 4 cancel. So this is the limit as x approaches 4 of x plus 11 over x plus 4. And substituting the 4, we get 4 plus 11 over 4 plus 4, which is 15/8. And that's the answer. Number 4. We change colors here. Number 4. The limit as x approaches -3 of 5x plus 9 over x. Okay. 5x plus 9. Okay, this is the limit as x approaches -3 of 5x plus 9 over x squared plus 6x plus 9. If I substitute, I definitely do not get 0 in the numerator. Okay, so that's -15 plus 9, that's -6. And in the denominator, if I substitute, I get positive 9 minus 18, 6 times -3 is 18, plus 9. So I get 0. So it's a number over 0. So it could be either positive infinity or negative infinity. Okay. So I will try with a number that is a little bit from the left and from the right. So a little bit before -3 and a little bit after -3. This is the limit as x approaches -3 from the left, let's say, of 5x plus 9 over x squared plus 6x plus 9. Right. A little bit before -3, that would be like -3.01. Okay, so this will be negative. Yeah, because it's 5 times -3, -15 plus 9 is -6. So here I get negative over -301 square is going to be positive 9 point something. Okay, I can try it with the calculator. I put -3.01 here. I actually get a positive. So that means that the limit from the left is negative, because negative divided by a positive is a negative infinity. If I try from the right, the limit as x approaches -3 from the right of the same expression, that's an x squared plus 6x plus 9. I will try with -2.99. I know that the -6 is still negative, and I put in -2.99 here, and I did it in my calculator, and I also get a positive. Okay, so it's negative divided by positive, that is negative infinity. Because these two are the same, that means that this one is the same, it's negative infinity. That's infinity. Okay, another trick in this one, it's not a trick, it's something you should realize. X squared plus 6x plus 9 factors to x plus 3 times x plus 3. So x plus 3 squared. These are the same. So because it is a square, let's say I put in -3.01. -3.01 plus 3 is -0.01. Square is positive 0.0001. If I put in -2.99 plus 3, it's positive 0.01. Square is 0.0001. It's positive because it's a square and these are real numbers. It's always going to be positive. So here, number 5. This limit 10x minus 20, 1 over x minus 1/2. All right. So yeah, number 5. The limit as x approaches 2 of 10x minus 20, 1 over x minus 1/2. If we substitute, we do get 0 over 0. So I am going to try to put it as a single fraction here. This is, well, 10x minus 20. And here we get a common denominator between those two fractions is 2x. This fraction, the denominator to go from x to 2x, you multiply by 2. 1 times 2 is 2. And in this one, 2x to make it, 2 to make it 2x is multiplied times x. 1 times x is x, so minus x. Okay, I'm going to do 2 things in this next step. First, I am going to factor the numerator. They have a common factor 10, so 10 times x minus 2 Then I'm going to, instead of divide, I'm going to multiply times the reciprocal. So that means this is 2x over 2 minus x. And this can be written as over 1. So the x minus 2 and the 2 minus x are not the same, they are opposites. That means when we cancel them, we can write -1 in one of them. Okay, so these cancel. When you divide opposites, you get a -1. So what we are left with is the limit as x approaches 2 of -10 times 2, -20x divided by 1. Substituting that, -20 times 2 is -40, and that's the answer. Next, sketch graphs with functions having the infinite discontinuity at 2. Okay, number 6, an infinite discontinuity at 2. So here's 2. An infinite discontinuity means it will have a vertical asymptote. There are many possibilities. One of them could be like this, and maybe coming from the same side. I mean, it could have also have been, oops, nope. It could have also have been, there's the asymptote, it could have been like this. One side up, one side down. This one's up, this one's down. I mean, many things. The 2 is there. All right, part B, ask a removable discontinuity at -3. Okay, so because it is removable, I'm just going to draw it. We needed it to have like a hole, and the -3 happens to be here. The axis wouldn't be there, would it? It would be on the other side. Okay, so yes, it's being here. There's a removable discontinuity. It doesn't matter if you draw a point above or a point below, as long as it's not there. Okay, number 7. Same thing, same type of question, a cusp at 4. Okay. A graph with a cusp at 4. A cusp there, and just make sure that it's at 4. So it's 4. That's where the cusp is. Does it have to be up and down? No, it could have been like this, or it could have been like, well, and then going up and then more up. I mean, as long as here is 4. It's a little peak. A step discontinuity at 1. Step discontinuity is when we have the limit from one side is different from the limit from the other side. So it could be like this, and like that, and it's at 1. So there's the 1. Doesn't matter which one of the 2 is filled, or neither of them, but not both. If both were filled, it wouldn't be a function. Number 8. For what value of p will the function be continuous at 2? And we have 25xp and 100x over p. Okay. Number 8. Okay. 25xp and 100x over p, and the rule changed at 2. Something like this. So basically, because we want it to be continuous, the limit from the left, which will be the value of this expression, the top expression, should be the same as the limit from the right, which is the value of this bottom expression. So I'm going to simply equal them when x is 2. So 25 times 2 times p has to be equal to 100 times 2 divided by p. So solving here we have 50p is equal to 200 over p. I'll move the p over here, so that is 50. You know what? Let's do it right. 50p squared is equal to 200 divided by 50. P squared must equal 4. Therefore, take the square root. P could either be positive 2 or negative 2. It had two solutions, positive or negative 2. This limit, the limit as x approaches, as x goes to infinity of 5x cubed plus 200x squared plus 7,000 over 2x to the 4 minus 7x squared plus 23. Okay, so number 9, limit as x goes to infinity of 5x cubed plus 7x, no, 200x squared plus 7,000. 200x squared plus 7,000 over 2x squared minus 7x squared, 2x to the 4th minus 7x squared plus 23. 2x to the 4th minus 7x squared plus 23. Now the largest power of the variable in the denominator is x to the 4th. So I'm going to multiply times this 1 over x to the 4, 1 over x. What's the next? X to the 4th power. Distribute this fraction over here. So we get, this is the limit as x goes to infinity of 5x cubed divided by x to the 4, so that's 5 over x, plus 200x squared times 1 divided by x to the 4, that's 200 over x squared, plus 7,000 over x to the 4th, over 2x to the 4 times 1 over x to the 4, that's just 2, minus 7 divided by x squared, same process, plus 23 divided by x to the 4th. Now, as x grows a lot, anything that is a constant number divided by a power of x, a positive power of x, goes to 0. So this goes to 0, this goes to 0, this goes to 0, this goes to 0, and this goes to 0. And so what we have is 0 over 2, which is 0. So the limit equals 0. Number 10. Limit as x goes to 3 of, okay. Square root of x plus 1 quantity minus 2. Okay. It's up. Yeah, got it there. The limit as x goes to 3 of the square root of x plus 1 minus 2 over x minus 3. The thing is, if you substitute, you get square root of 4, which is 2 minus 2, 0, over 3 minus 3, which is 0. So we multiply by the conjugate. And the conjugate of the numerator, we want to rationalize this one, the one that as a root is basically the same thing with a sign between the two terms that are, in this case, subtracting, changed. So this is the square root of x plus 1 plus 2. And this fraction has to be a 1, so we just write the same thing. All right. So this multiplying out, let's see, this is the limit as x approaches 3. In the denominator, we just write it out. X minus 3 times square root of x plus 1 plus 2. In the denominator, we actually multiply out. Square root of x plus 1 times square root of x plus 1 is just x plus 1. Because it's two square roots being multiplied. Square root of x times plus 1 times positive 2. It's just 2 square root of x plus 1. But then we have negative 2 times positive a square root of x plus 1. So that would be negative 2 square root of x plus 1, which added with the original one, they will cancel. I will not even write it. So you get the same thing, one positive and one negative. And then the next one is negative 2 times positive 2, that's negative 4. All right, so what we have is, I'll simplify limit as x approaches 3. In the numerator, we get x plus 1 minus 4, that's x minus 3, over x minus 3 times the square root of x plus 1 plus 2. And you can see that these two cancel. They're the same thing, so I put a 1. I'm going to put a 1 here, but times this, it's going to be this. So what we have is, this is the limit as x approaches 3 of 1 over the square root of x plus 1 plus 2. Substituting the 3 now, I have no longer division by 0. So that is 1 over the square root of 3 plus 1 plus 2, which is 1 over the square root of 4 plus 2, or 1 over 2 plus 2, or finally 1/4. And that's it. Okay. Let's stop sharing. And I want to stop.